and today we're learning about derivatives. So the definition of derivative is the slope at a certain point. And we know by definition that slope is a change in delta y divided by change in delta x. And in this case, the derivative is just figuring out what is the slope is at a certain point, just this point. So if we take a small portion of delta x, which is approaching 0, and we observe just change in delta y. So by its own definition, the derivative of fx is equal to fx plus delta x minus fx divided by delta x, as delta x approaches 0. And this is very similar to slope. And now we're taking an example of the derivative of sine x. So by its own definition, we can get limit as delta x approaches 0, sine x plus delta x minus sine x divided by delta x. And this is equal to, and we know that there's a formula for the trigonometry. So here, and in this case, it is equal to sine x cosine delta x minus or plus sine delta x cosine x minus sine x divided by delta x. We know that when cosine delta x as limit delta x approaches 0, this is basically approaching cosine 0, which is equal to 1. So these two terms cancels each other out, and leaving out to be cosine x times sine delta x divided by 6. And we know that when limit delta x approaches 0, sine x is basically 1, because this term is really close to delta x. So the derivative of sine x is equal to cosine x. Similarly, we can figure out the derivative of the cosine x to be, we also have a formula for this one, so it is cosine x cosine delta x minus sine x sine delta x minus cosine divided by this. And this term is just approaching 1, and this term is approaching delta x. So we have these, and this term cancels out, and this term and this term cancels out, so it is equal to sine x. Now we prove the derivative of ln x, so it is a natural log, natural log. So first, by its own definition, it is this ln x plus, again, my god, x divided by x is equal to, we also know that ln a minus ln b is equal to ln a divided by b, so it is equal to ln 1 plus delta x and this, because we move this to that and divided by here. And so now we have this term, and limit delta x is approaching 0. And now if we times the term by dx and x divided by delta x, ln 1 plus delta x, and move it to that side, we have this ln 1 plus x. So what's going on here? And we also know that a ln b is equal to ab to the power of a. You know that? And by observing this term, we have and also by its own definition of E. So it is limit n approaches infinity, and this one is 1 over n, and this one is n. So this is basically equal to this term, because this one is approaching very, very small, and this one's going to infinity, so this one's basically 1 over x times ln times e, and this one is just equal to 1, so the derivative of ln x is equal to 1 over x. And now we take a look at the derivative of x to the power of n. So now we set a function which is y equal to xn, and we take the derivative of y. No, derivative of x, wait, this is not good. I'll just put, this way is better. And take the derivative now. d dx is equal to y times dy dx equal to n times x. And so we have dy dx equal to n divided by x times xn. So which is x, n times x to the power of n minus 1. And this part, don't worry about, we'll talk about it. It is a chain rule, okay? We'll talk about it just now. So for the chain rule, the proof is quite easy. The derivative of f to x is just equal to, by its own definition, it is limit that x approaches 0. And so it is the term f gx plus g or dg, or just change g. Oh my god. By x. Yes. And this is equal to this. Oh my god, I'm messing up. And there's a minus over here. Gx. So this part is equal to f gx plus delta g divided by delta g times delta g over delta x, and this part is just taking the derivative of g dg dx, and this part is just taking the derivative of the f dg. So this proves the theorem. And for this part, just taking the d dx ln y is equal to d dy ln y times dy dx. And now we're going to the product rule, which is, by its own definition, is this. Fx plus delta x g x plus delta x minus fx gx divided by delta x, which we can write out as to be the gx plus minus f x gx plus delta x plus fx gx plus delta x minus fx. It's pretty nice. These two terms, when plus together, they're equal to 0. So we now take a look at this part. Wait. At this part. We see that only this part is moving, so it is just basically the derivative of f times g x plus delta x. And this term is basically equal to f x times dg dx. And when delta x is approaching 0, this term is just approaching gx. So which proves the theorem that d dx fg is equal to f. This just means derivative and plus g f. And the quotient rule is very similar. Does d dx f over g. We can treat 1 over g as a function. So it is very similar to the product rule. So we have this. And now we can prove that it is equal to f g minus g f divided by g squared. It is pretty simple. I'm just too late.